Hello everyone, so in this video, let us talk about one more easy problem from LeetCode. The problem name is count special quadruplets. So problem statement goes like this, that you are given 0 index integer array nums. You have to return the different distinct quadruplets such that A, B, C, D, so that this condition is met such that nums of A plus nums of B plus nums of C should be equal to nums of D. So A, B, C, D are actually different indexes. So you just actually have to choose 4 different indexes such that the sum of the 3 index should be equal to the 4th index, and these indexes should be in an increasing manner. Okay, they cannot be like same. You cannot choose two index to be same. That's the problem statement. Now, if you take a look at this example, you can choose these three indexes 1 plus 2 plus 3, and it is equal to this index, and all of them are increasing. So that's the complete problem statement. Now, according to the constraints, what you can easily understand is that you can do this complete problem in brute force manner also, because the constraints are pretty much small. So what you can do is that you can do 4 nested for loops, and for all the for loops, what you can do is that you can just check out that this condition is met. If this condition is met, return the number of quadruplets that are satisfying this condition, just return the answer. Okay, that is the O of n to the power 4 type of operation, and it is simply like passing the complete time complexity because the constraints are pretty much small. But can you improve the time complexity? That's the complete problem. Now, can we do that? Can we do this instead of O of n 4 to O of n cube? Can we decrease one time complexity, like one for loop? For that, whenever you are decreasing any, let's say, time complexity to a very significant amount, let's say from one end, like n to 4 to n power 3, then you have to somehow use the memory aspect. So you have to somewhat use some extra memory. So in the original O of n4 operations, you are not using any extra memory. But if you're moving to this approach, you have to somehow store some information so that this will be helpful to increasing the speed of your program. And that is the complete thing you have to first come up. Now, how can you optimize your overall time complexity? What you can see is that somehow can I just find out and do a for loop for the first 3 indexes, that A, B, and C. Can I just do 3 nested for loop for A, B, and C? And according to that, can I directly just find out how many number of nums D, like how many types of indexes are present that has this value? Can I somehow find out this? How can I find out this? What you can say is that, let's just take a small example of small array. I'm not filling some value, but let's just take some example. What you can say is that, let's assume that there's some imaginary line passing like this at the very end. Now, what you're trying to say here is that all the numbers to the right of this imaginary line are the ones that are eligible for the index to be in D. What I mean by this is that all the numbers that are right side of this imaginary line are the ones that are eligible to come up as an index as D. Okay. For the first example, let's take example that there is no number on the right hand side of this imaginary line. So nothing is compatible for D. What I'm trying to say here is that I will make three nested for loops, and the 3 nested for loops will be such that I have to find out 3 triplets. Like any triplet, 3 nested for loop means that I want to find out triplet. But triplet, I will make such that I have to take 3 indexes A, B, and C. Okay. Now what I'll do is that I will always, like, I will put my C at just one step before this imaginary line. I will always put C here. And among all of the rest of the numbers, I can put A and B according to that. So let's say I put B here, I can put A here. So there will be nested for loops for finding out all the pairs, given that C is always here. And for all the A and B, you can just make out for loop the different pairs from here. So I just have to find triplet. So C is here, A and B, you can form any pair between this. Now, obviously, this condition is meant that A is on the very left, B is here, C is here, and then all the elements to the right hand side are eligible for D. Okay. Now, as we move this C to the left hand side, see what happened. The thing that happened here is, if I just remove out some of the things, let's just imagine that if I just move this imaginary line, if I just remove this imaginary line, let's say, okay, from here to let's say here, let's say there are Two more blocks. Now there are two blocks that are added on the right side of this imaginary line. Now what actually this means that C will always be here. Now I can form any pair of A and B on this rest of the blocks, and D will all be the blocks that are present on the right side of this whole line. Now what I can do is that I can make a map. As I move this imaginary line one step at a time from left, like from the right hand side to the left hand side, I will keep on adding whatever element is here to the map. Let's say this imaginary line is at this point at any given point in time. So as this imaginary line moves to the left hand side, I will keep on adding these elements to the map. And this map store all the elements on the right hand side of this imaginary line which are negligible for D. Okay, now for any triplet that has a sum on the left hand side of the imaginary line, I will find out how many like single values are there on the right hand side of the map, or like this imaginary line that are present inside the map that are negligible for D. Okay, let's take a small example to understand all of this. Or in the code itself, what we're eventually doing is that we have done now 3 nested for loops, as you can see. Okay, now what these 3 nested for loops will do, let's talk about that. The nested for loop will start from the very end. So this I start from the very n minus 1, the last element. This start from one element before. This element start from one before that. So this I is actually the imaginary line. Okay, and what I'm trying to say here is that, let's say if I'm at any given this point, then this I is this element. Let's say you can assume that this is C also, or you can just state I also. Okay, and all the elements before it. Okay, then you will do a nested for loop for all the ij's. Okay, let's say you will do nested for loop for, let's say, B and C, B and A. This will do nested for loops for all this part. And what you can see is that how I will check this, that what the element on the right hand side of this imaginary line, that is right hand side of C, I will put it inside the map. Now what you can see is that the maximum value of the map can be up to 100, and thus I've created a maximum value of 100. Now what you can see here is that if the three values I plus j plus k, if it is less than 100, because why? Because as you can see that if nums of I is less than equal to 100, then all the numbers present in nums of I is less than equal to 100, and thus if this condition should be met, then the D should also be less than equal to 100, and thus because D is present in nums, and thus if D is present in nums, it should always be less than equal to 100, and thus I will only take about all those triplets whose total sum is less than equal to 100. Then what I'll do is I will find out how many occurrence of that sum of this triplet occurs in map. So I will just check out and increment the answer. Now what you can see is that these two for loops will find out all the pairs with this as a triplet and check it for this. Now when all the pairs are exhausted, after these two for loops, as you can see here, after these two for loops end, which means that now I have formed all the pairs, and accordingly with this C or let's say any I, all the triplets are made. Then I want to move this imaginary line one step on the left hand side, which means that whatever my C is there, okay, now I have to take all the pairs such that now C is here. So C is always fixed. Let's say C is fixed and all the A and B are here. Okay, and then because C is fixed, I will only make pairs in the increasing order on the left hand side of C, and all them on the right hand side of C are added inside the map. Okay, as you can see, as the C is completed, I will take the ith element and add it inside the map. So what it actually helps is that all the elements on the right hand side of C are inside the map, which actually help us to do, and just like, let's say, because it's a map, you can do it like it's just a standard, let's say, array only, so you can do it in O of 1 only, because it's not actually a map, like it's just a let's say hash array only, or like array only. So you can just do an O of 1 and find out what element and how much time its frequency of element is present on the right hand side of this particular value, because I'm only adding all the elements on the right hand side of the C only, because as I'm coming here, it guarantees that whatever element I choose as D will be on the right hand side of the 3 pointers that I'm choosing on the left hand side of C, such that this element can be chosen from all the elements on the right hand side, and this condition is satisfied, that A is greater than, like A is smaller than B and C is greater than 10 and D is the most greater. So this condition is met. That is why we are doing this whole iteration from right till left and not from left to right. Okay, so that as we move our C, I will add more elements in the map, and this condition is met, and you will just increment the answer. That's the complete logic in the code part for this particular problem. Now it is solved in O of n cube. If you still have any doubts, you can mention in the comment box, or you can join my Telegram channel. You can contact me anywhere if you want, if you have any doubts. Thank you for watching this video till the end. I will see you in the next video coding, and bye.